All right, so today we are going to work on lesson 8.1, which is the sine law. And the goals today are to label a triangle according to sine law, and it doesn't have to be a right angle triangle. And secondly, to use the sine law to solve for missing sides and missing angles of any triangle. All right, so as I said, it doesn't need to be a right angle triangle in order to use sine law. So if we took a triangle like this one and we were to label it, the angles are always labeled with capital letters. So you'll notice there's capital A, capital B, angle B, capital C, angle C. The sides are labeled with lowercase or small letters, and they need to be set up so that they're opposite their capital angle counterparts. So capital C is over here, it's an obtuse angle. That means little c is just opposite. Angle A, which is over here, opposite this angle, we will have side A labeled with a small letter A. A. And then for B, angle B, opposite B, we'll have a little. And that's how you label the triangle. Okay. And the law states that the ratio between the side and the sine of the angles are all equal. So A over sine A equals B over sine B equals C over sine C. Okay, let's look at an example. Now, in this example, it says to calculate an unknown length using sine law. So let's make our x value the one up here in the corner. So sorry, my apologies. Have the x down here. So it's easiest if you use the law by labeling the triangle. So in this case, we could say this is angle A, angle B, angle C, making this little a, little b, little b, and little c. Okay, so we are going to write out what we need to use in the question. So we definitely need a and little a. We won't need all three, but we will need a and sine a, because a is the missing value. And we're looking for a complete pair. So we don't know anything related to C. We don't know the angle, we don't know the side. But we do know for B. So we're going to use B over sine B. And fill in what we have, and then it's once again a case of cross multiply. So A, we're going to use the letter X, it's unknown. For sine A, we're going to take the sine of 55 degrees. B will be 9.2 centimeters over sine of 70 degrees. And then cross multiplication. So these two are multiplied, and it's divided by this. Remember, when you type in sine of anything, you just get a decimal value. So consider it a number. 9.2 times sine 55 divided by sine 70. And on your calculator, if you want to do it in one step, I would put a bracket around the top two to make sure that you're doing that before you're dividing. Okay, or you can do it in two steps. Get the answer, then divide by sine 70. It's approximately 8.0 centimeters. The next example is to calculate the unknown angles using sine law. So this triangle, if it's labeled here PQR, we were trying to find all the angles inside. You need to start with this one here, because that's the only information we know about angles is that the exterior angle is 124. So this angle we could find by remembering that supplementary angles equal 180, subtracting 124, and you will get 56 degrees for angle P. Now that helps because we also know side P, so we have a complete ratio. We have half of the information we need for angle Q, and we don't know any, sorry, for side Q, we don't know angle Q. We don't know anything about R. So let's start with P and sine P, and Q and sine Q. So for side P, it's 98 over the sine of 56 degrees. Q is 112, sine of an angle we don't know, angle Q. So when you're doing the cross multiplication here, just keep in mind those two are diagonal, so you multiply, divide by 98. At this point, we're still isolating sine q and not just q. So 112 times sine 56 divided by 98 on your calculator like you did before. So multiply the top, divide by the bottom. And you will get a long decimal for sine q, something that looks approximately like this, 0.9474. Oh, sorry, 5. Because normally, as I said, keep 4 decimal places. So round up. 47 would be 5. But you can also, as you're pressing second function, just take the answer and use that. So you need to take the inverse of the answer you just got. Move that over slightly. Because that's how you find angles. Use the inverse button. Second function sine of 0.947472, etc., etc. Take that answer, and you get approximately 71 degrees. All right, so the next question, we need to draw the picture ourselves. You have to understand everything in the problem. You have a wall, and the wall is 1.4 meters long, and it started to lean. So originally, if you think of a wall, you have the floor and a wall, and it's a right angle. But since the wall is leaning, erase the wall, and we're going to have it lean. The original floor, here it is. The wall is leaning, and it now makes an angle of 80 degrees with the ground. So this is the ground, the wall. The wall and the ground make an angle of 80 degrees. A 2.0 or 2-meter board is jammed between the top of the wall, right up here, and the ground to prop it up. So it's a 2.0 meter board, and so we can label it for the picture. This is the board. Okay, so 2.0 meter board is jammed between the top of the wall and the ground to prop up the wall. Assume the ground is level. First question. What angle to the nearest degree does the board make with the ground? The angle we're looking for is this angle here. And I'm just going to take a quick snapshot. Give me a second. Okay, so here's the diagram. We can label everything A, B, C. It's helpful. And what we're looking for is the board and the ground. So we're looking for angle A. And in order to use sine law, remember you need a complete ratio or complete pair. So we have side C and angle C. They're corresponding. So we will use that. Sorry, forgot to label the 1.4. The wall is 1.4 meters. The other piece of information we need to use, there it is. So we are going to use A and little a and C and little c. So A over sine A equals C over sine C. Choose any two ratios depending on what you need in the question. So 1.4 over sine of an angle we don't know, sine A, 2.0 over sine of 80 degrees. Then we will cross multiply. So 1.4 multiplied by sine 80 divided by 2. So sine A is isolated. These are opposite each other. Multiply them. Divide by. Multiply those, then divide. You will get, once again, a decimal because you're looking for an angle. So we're going to need the second function. But for now, your calculator should give you something like 0.6894-ish, if I approximate. And to find A, I need to take the inverse or second function of sine of this long answer. So I could just put my answer right here. Instead, you could just say answer. And you should get A is approximately 44 degrees. So the angle that the board makes with the ground is 44. Sorry. Question B, what angle to the nearest degree does the board make with the wall? So if we look at our diagram again, we want to know the angle that the board makes with the wall. And in our last question, we found that this angle here is 44 degrees. We already have 44 degrees, and we have 80 degrees. So for this question, if you just take the sum of the angles, which is 180, subtract the 44, subtract the 80. You will have 56 degrees as angle B up here at the top, the angle that the board makes with the wall. And last but not least, it says how far to the nearest tenth of a meter is the board from the base of the wall. So really, we want to know what's happening here on the ground. So the ground is side B. We're looking for side B. So that has to correspond with sine of B. And secondly, you choose another ratio that you have. We have A in sine A, but sine A was an angle we found. So just in case we made a mistake calculating that, it's safer to choose the information that was given in the question. So I'm using the red information in the picture because it was given, and that way my calculations will not interfere. Side B, we're looking for the sine of 56 degrees. Side C is 2, and the sine of 80 degrees. Okay. Cross multiply, divide. In this case, we're finding a side, so we won't have to rely on using second function. That's only for finding angles. On your calculator, multiply 2 times sine 56, divide that answer by sine 80, and you will get approximately 1.7 meters. And that's it. See you tomorrow, guys.